Hello again. In this video, I'm still on page 23 of the diagnostic test, and I'm going to be going over question 36 and 37. So let's take a look. Both of these, I think, make pretty good sense. So this won't take long to explain. It says, in a particular town, 40% of the voters are registered Democrats, 35 are Republicans, and the last percentage, 25 independents. Now they've asked, if we took a sample of 200 people, how many independents would we expect? And so probably the best way to explain this is if I made a table and just used my common sense. I tried to kind of scribble a table here. If 100 people were in the town, 40 would be Democrats, 35 Republican, 25 would be independent. That's what we mean by the word percent. And so one easy way to come up with an answer would just be well, instead of 100 people in my sample or in my town, I just need to double that. So if there were 200 people in my town, I would expect twice that, or 200 people in my sample. So again, it looks like I should expect 50. A lot of people got that right. Then I'm thinking to myself, okay, there is actually a formula on the formula sheet, and we use this quite a bit. If n is 100, then we use the formula, the number of people in my sample times the proportion. The proportion of people that were independent. Here we know that 25% were independent, so I'm going to put a 0.25. But instead of 100 people, we actually had 200 in our sample, and 200 times 0.25 is still 50. So it both makes sense from a logic standpoint and from a formula standpoint that is in the back of the book. Now let's take a look at this question, 37. And as we look at this question, we notice it's a margin of error question. So once again, I'm going to go to my formula sheet, and I'm going to take some notes on here. So if you missed this question, you should definitely jot down these notes because I think they would be valuable for you to make sure you're not missing it the next time. So here's my notes. And it kind of helps me explain what margin of error is. So my formula says in the book, if I take a sample, then I should get the same average as the overall average of the population. So if 58% of the people watch this show, then the average of my sample should also be 0.58. Okay, so mu is 0.58, x bar is 0.58, my average I suspect is 0.58. That's my statistic. However, we know that there is variability in the world, so we actually expect some amount of fluctuation from our answers. And that's where this margin of error comes in. So the margin of error is my critical value times the standard deviation of my sample. So also known as the standard deviation of the statistic. And that's what my formula sheet says. So when I take a look at that, I just read in the question. They're not really asking me to calculate this. They're actually telling me what got calculated. And they want me to tell you what it means. So ultimately, the study produced 58% of the people watch, plus or minus 4%. And as I glance through these, the one that makes the most sense is the one that talks about 52 to 62, because that's ultimately what's happening there. So let's read a little bit. It says the margin of error of plus or minus 4%, or plus or minus 0.04, ultimately is telling us that the sample percentage that we would expect would be within 4% of that average, and our average is 0.58. So when we look at that, when we add 0.04 to 0.58, we get 52%, and when we add, we get 62%. When we subtract, we get 52%. And that's exactly what we got. That's pretty much how answer D reads. The actual percentage who preferred bachelor probably is between that Oh, I think I said 52. Sorry about that. I think I jotted that down wrong. So that's 54. So 0.58 plus 0.04, we get 62. 0.58 minus 0.4, we get 0.54. And so definitely D explains what is the margin of error, why do we calculate it, and why is it useful for us. And so this is how we might see it printed in the newspaper. Awesome. Thanks for joining. Take care.